Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we'll be going to learn about spanning trees, minimum cost spanning trees. This topic you'll find in third unit as topic number 2. So I'm just dividing the whole topic into 3 different videos for the convenience to understand the topic. The first video, this video is going to be on what is spanning tree and how to find out the minimum cost spanning tree. And the second video continuation part you'll find in the same channel. The continuation part of this video is about how to find out minimum cost spanning tree using Prim's algorithm and using Kruskal algorithm. So these are what 3 videos, continuation videos to understand about minimum cost spanning trees. Okay. And the very most important point is you have lab to implement this concept. Okay, you'll find this experiment in the lab curriculum. So my sincere advice to all of you is you just focus on the topic minimum cost spanning tree to implement this in practical scenario. Okay, let's get started now. So what is spanning tree? So spanning tree is, let G is equal to V comma E, where G is a graph and it is a undirected connected graph. Now a subgraph T is equal to V comma E dash of G is a spanning tree of G if and only if T is a tree. Now I'm introducing 2 terms, which is G and T. Okay. Now G is a graph, T is a subgraph. That means T is a subset of G. So G basically have what? Vertices and edges. So when I told that T is a subgraph of graph, now T also have vertices. T is a spanning tree which also have edges. Now the spanning tree will have the same number of vertices as graph is having. That means spanning tree number of vertices are equal to V of a graph. Spanning tree number of edges is equal to number of vertices minus 1. Now this T belongs to T is equal to V comma E dash. V is V, E dash is equal to V minus 1. Now T is a spanning tree. So this is what the definition of spanning tree. Now let's see an example how a graph is called as a spanning tree. Now take some graph, and this is the graph which is connected graph. I am calling this connected graph, and it is undirected connected graph. Undirected, I don't have any direction, that I cannot tell that A whether I am moving from A to B or something. So we were seen in the graph already. For an undirected connected graph, U comma V is equal to V comma U. Right, now let's understand the phenomena of spanning tree. Now this is the graph G. G is equal to what? V comma E. Now S is a spanning tree and it is a subgraph of G. Now S is equal to V comma E dash. V is what? V is number of vertices in spanning tree. It is always equal to number of vertices in the graph. That means how many vertices I can see over here. If G number of vertices, if G is equal to V comma E, if V value is over here 4, A, B, C, D, total 4 vertices in the graph G. Now S is a subgraph. Now S is a spanning tree which is a subgraph of G. Now the number of vertices in subgraph or the spanning tree is what? It is exactly equivalent to V. That's what we wrote here. G is equal to V comma E. S is equal to V comma E dash. So there is no change in V. That means the same number of vertices will be again you can see in the spanning tree. Now the difference will come respective to the number of edges. So G is equal to V comma E. E is number of edges. S is a subgraph. S is a spanning tree which is subgraph of G. Now number of edges is E dash, and E dash is not equal to E. E dash is what? Vertices minus 1. So how many vertices you have? 4 vertices in the spanning tree. So V minus 1, that is 4 minus 1 equal to 3. So the number of edges of spanning tree should be 3. As far as this example is concerned, S is equal to V comma E dash, means V is 4, number of vertices are 4, number of edges are 3. Now then it is called as a spanning tree. We'll see an example. We'll see different spanning trees what I can get from this graph. Okay. Now look at this. So I have this graph. As far as the formula is considered, S is a spanning tree where it should have 4 comma 3 for this example. 4 is number of vertices, E is number of edges. Now how many spanning trees I can draw is A to B is 1 and A to C is 1, B to D is 1. So how many vertices you can see? 4. How many edges you can see? 1, 2, 3. So now it is a spanning tree. In other sense, you can say something this, that a graph which doesn't have any cycle is also called a spanning tree. I repeat, a graph which doesn't have a cycle is called as spanning tree. In other sense, you can say that if a graph is having n number of edges, spanning tree always will have n minus 1 edges. So these are the common definitions what we can give for spanning tree. And so why the reason I have to neglect, or why I have to cut this edge? Why not this? Yes, it is also possible. So you can take that also. So A to C, now B, C to D. So I do not consider this edge. So, and hence it is spanning tree. What is spanning tree? It should have 4 number of vertices as far as example is considered, and 3 number of edges. 4 number of vertices, 3 number of edges. And can I get one more spanning tree? For sure you will get one more spanning tree. A, B, D, C. Now even this also is spanning tree. Likewise, how many spanning trees I can generate? So that's also a question. Now we'll see for an example how to generate a spanning tree. Now we'll see an example. Before we'll see an example, let's discuss about applications of spanning tree. There are 2 applications of spanning tree. The one is the spanning tree for the electronic network is obtained. And another application of spanning tree arises from the property that a spanning tree is a minimal subgraph. These are what? Applications of spanning tree. Now we'll see the example. Here in the example, G is equal to V comma E. How many number of vertices you could able to see? 6 number of vertices, correct? How many edges you could able to see? That edges are nothing but pair, right? That means you can write 1 comma 2, 1 comma 2, 2 comma 3, 3 comma 4 and dash. So as it is undirected connected graph, that means U comma V is equal to V comma U. So 1 comma 2 is possible, 2 comma 1 is also possible. So you can write all the edges what are possible in this graph. Now our aim is what? To write different spanning trees for this graph. Now consider spanning tree is a subgraph or subset. G is equal to, that G dash is equal to V comma E dash. That means what? G dash is a subset of graph. G dash is equal to V comma E dash, where V is equal to V. That means this V is graph G, this V is S. Now E is equal to V minus 1, right? Now how many vertices in the spanning tree? That S is equal to V comma E dash. That is number of vertices are 6, E dash value is what? V minus 1. That means 5. So I should have a spanning tree with 6 number of vertices and 5 number of edges. Now let's see, will the same thing will get or not. 1 comma 2, 2 comma 3, 3 comma 4, 4 to 5 and 5 to 6. So this is a spanning tree. What is spanning tree? The graph which doesn't have any cycle is called as a spanning tree. Now, if I frame this, if I have a line or edge in between of these two, it becomes a graph. So that's what I'm neglecting this edge. That's what I'm not considering the edge. Now it is a spanning tree. Now question comes into our mind, why the reason I have to take out this edge? Why not this, or why not this, or why not this? So when you have a possible feasible solutions of these many, you can apply greedy method, right? Now before we see that, let's first of all find out how many, for a given graph, how many spanning trees we can generate. For a given graph, how many spanning trees we can generate. Now let's see it. That means how many vertices we have? 6 vertices I have. And how many edges I have to take? 5, right? Because we were just now completed the phenomena that a number of edges of a spanning tree is equal to v minus 1. That means v is what? 6 minus 1, which is 5. So when you have 6 vertices, you have to choose only 5 edges. So it is something like NCR, correct? So what is 65 value? If you take NCR, that is n factorial r by r factorial into n minus r factorial. So we'll write what? 6 factorial 5 factorial into 6 minus 5 factorial, which is, I am writing 6 factorial is 6 into 5 factorial into 1 factorial. Now it is 6. That means 6C5 is equal to 6. So I'll get 6 possible spanning trees. From this graph, I can write 6 different spanning trees, correct? So the one spanning tree is what? I can take out this edge. That means I have 1, 2, 3, 4, 5, 6 and this. This is one spanning tree. And I can also have the other spanning tree by taking out this edge. Then I'll be having spanning tree, correct? 3 to 4, 4 to 5, 5 to 6. This is also one spanning tree. So likewise, I can take all these edges for each time, not in one shot all the edges. In one shot, we'll take one edge out. That is of v minus 1. Edges, possible number of edges in a spanning tree is equal to v minus 1. Always you have to ensure that it is v minus 1 or not, the number of edges in the spanning tree. So finally, for this graph, you can get 6 spanning trees. Okay. Now we'll take an example. We'll take another example. This example is what? Connected weighted graph. In this example, let's find out the spanning tree. So I'll give a formula for the spanning tree to generate when you have a question. Possibly there will be a question from this area. When you have a question, the question will be something like this. You will be given with a graph and asking that to find the number of feasible spanning trees from the graph. Then the formula is what? Number of edges combinations v minus 1. This is what the formula. That's what we were seeing just before, right? Example 6C5 is equal to 6. You can give this example for the examination purpose. And the next way of asking the question is what? The same graph, but they can also give something like this. 1, 2, 3, 4, 5, 6. So here only you have one cycle. What if I have this? If I have this line, then how many cycles you can see? You have to take out this cycle, and here also one more cycle you are getting. So by by deleting this or by not considering this, you can make a spanning tree. So you have to change the formula when you have cycles in the graph. When you have a single cycle, then the formula is this. When you have a two cycles, then the formula is E C V minus 1 minus number of cycles. Minus number of cycles. This is what the formula which is useful to generate spanning trees, feasible spanning trees from a graph. Right? Now we'll see some example. This example, connected weighted graph. So as far as this example is considered, how many vertices you have? 4 vertices we have. And how many edges to become a spanning tree? V minus 1, where it is 3. Now what we'll do is, we will be going to write 1, 2, 3 and 4. Now, so this is one feasible solution. What is the feasible solution? You will be going to get only the 3 things, right? Because as far as the formula is considered, you will be having only 3 edges. So this is what spanning tree. Now, what is the spanning tree cost? The cost of the spanning tree is what? Individual edges cost sum. The sum of individual edges cost. That means 5 plus 3 plus 6 cost is equal to 14. Now the other spanning tree, other feasible solution from the same graph, 1, 2, 2, 3. Now it is 4, 3, 6. Now what is the cost of this one? 13. So you can draw or you can get more spanning trees, right? As the formula suggests us, you can take more spanning trees, 1, 2, 3. Now this is also one spanning tree, correct? Now, so after you calculated all the cost of different spanning trees, choosing the minimum cost spanning tree, we will choose the minimum cost spanning tree. For this, we'll apply greedy method. Why greedy method? Greedy method is applicable when you have a optimization problem. Now, what is this optimization problem? Optimization problem is applicable on feasible solution when the result of feasible solution is either maximization or minimization. So this spanning tree is what? Minimization problem. Spanning tree is minimization problem. There are 2 techniques to find out minimum cost spanning tree. One is Prim's algorithm, the other one is Kruskal algorithm. So next video we'll continue to discuss about how to find minimum cost spanning tree using Prim's algorithm and the same using Kruskal algorithm. Thank you all.